So my presentation is limited bandwidth applications. It's probably not appropriately named. It should be limited or no connection applications at times. And we, at Solutions Tree, we came across a potential client who was in this situation. I was intrigued by it, as well as another developer. And what it was, let's see if I could do this here. What the business problem was that it was applications running while on the road, or it could be any place. I'm using this as the example, where the bandwidth and connectivity issues are common. So most people, if the apps are at your desk, that's not an issue usually. But imagine if you're in a car, if you're someplace, if you're a U-Haul guy, or if you're doing estimations on the road and you lose your connectivity, or if you have low connectivity. So that's the situation we ran into. The specific situation is something similar to this. I won't mention the client or anything more specific than this, but imagine a police department application retrieving large amounts of data on warrants or criminal background checks. So that was the sort of the application. So the typical scenario, police are following a car. They want to run a check on the license plate as if they are driving through dead zones and tunnels. So I've never experienced this. Has anyone experienced this? I know one person has, because she's cars.
All the time.
Okay, you're not the only other. Right, right. Okay, make note of that. So I thought this was interesting, because most of the business apps we do, you know, some number of users or sitting at a desk, and so this was interesting here.
Well, like on Google Maps, if you're out in a rural area,
yeah,
it'll map out the general highways, and when you zoom in, if you lose connection, it just kind of like, you know, it doesn't have all the details, and it fills it in later.
Yeah. Do you know how they do that?
Some kind of caching.
Okay, yeah. So if anyone knows how, I'd be interested to know how. So
I know who to call.
So the standard architecture that a lot of people, well, just the standard architecture in general, what people build applications on, doesn't really work, right? We can't just have a client talking to a server and saying, give me this, give me that, or update this. And the connection could be lost. RESTful API, assuming it's RESTful APIs that we're doing what we want to do, it never completes. So the page, you have to refresh the page. And so does that really work? You know, can you really refresh a page? Is that really a good solution? I mean, I don't think so. Maybe some API is complete and the page is partially built. You know, not ideal. As long as it wakes up and does something else. Manual page refreshes, but it's not really that good. So actually, before I get to solutions that I thought of, does anyone have any solutions? Go ahead.
More client-rendered UIs where you're fetching data in the background and be able to kind of render the UI through the application itself and the data that it has.
So, right, so the client would, what do you mean in the background? What is in the back?
Using something like your worker thread to be able to kind of pull a RESTful API for just refresh your data.
Right. So let's say the connection is lost. What happens to that worker thread?
It would kind of time out, kind of requesting or retrieving it. But the responsibility of refreshing the page or keeping the page up to date would still be the responsibility of the app. It would still be kind of local to the application with the data that it has.
Use some polling mechanism that you are keep checking.
Just keep checking, like a polling. Okay. Okay. Anyone else? Yeah.
Just one thing. Okay. I mean, we had a similar situation in one of the applications. A little tricky. I mean, if you know ahead like what kind of data you want, you pull it and store it in the local storage. But again, there is always a limitation for how much data you can store in the local storage.
Right.
And then when you're offline, you can operate on the data. And I guess there are some patterns, like for each change, each modification the user is doing, they're tracked on a sequence basis, like a event. Like so, the user modifies the record, searches the record, updates the records, everything is stored in the local storage. And as soon as the connectivity is gained, you start dispatching even one by one in the sequence based on the timestamp or something. The server should be able to process the sequence. So
So that's good for updates, right? So if you're doing updates, that's good for the local storage. If you're doing retrievals, though, let's say you had to pull back a whole JSON tree or something, then local storage doesn't help as much, or does it still?
Well, I mean, every browser has this limitation of how much local storage it can hold, and but I guess that's the only option.
All right. Anyone else?
Yeah, I mean, it seems kind of more like a server cluster issue. So you've got a couple of different kind of services you're looking at. One is data retrieval, and then the other is issuing commands potentially. I think the scenario that you're talking about with the police, it's you could have the infrastructure, powered infrastructure as opposed to a regular mobile app, which is going to suck all the juice out of your device.
Right.
Trying to run, if you've got a page or an app, and a local server like a Node.js or whatever with some amount of storage space, non-memory storage space, non-active RAM storage space, then you can definitely cache up. So you read a plate, you can cache that and say, hey, this is important. I don't have a connection right now. But basically, the server just spins and checks to say,
checks the client. The client is connected.
Well, I mean, the local server. So your mini server that runs, in the car is going to be checking the other server, saying,
okay.
Do I have connectivity?
So polling. So polling, like Prashant was saying.
Threads, and it would have a thread pool that
right.
And that. And then the application would read against that mini server.
Right.
So you're kind of describing like a WebSocket type thing, or is that what we kind of?
Right. That's another WebSockets. Yeah. Socket.io connection.
So I mean, the idea with Socket.io is that you have to at least be a good enough connection area where you get the web page that you want. I mean, we're talking about a web page. We're not talking about a client-side application, a mobile application that's already been installed on the.
Right.
You can set up all your sockets so that you're constantly pulling the connection, and you can be buffering data if there's pull requests or things like that. You can have them buffered up.
Right. And the mobile versus web issue, I think it's still the same issue, but there's differences,
It'd be
right?
nice if the protocol or the solution had a way to not retransmit stuff that you already got. So some kind of an integrity checker that if you have a partial transfer that it resumed where it left off. So you have to waste. If your bandwidth is already hampered, you don't want to waste that bandwidth you already got from some of the teams.
Yeah.
But I think some of the web protocols, they assume that you can just do a refresh, but you need something that's a more reliable transfer protocol.
Right. That's a great point.
3 years.
So are you using like a local storage for the reference data, right? It's typically, what do you do, like some reference data?
Yeah, so you don't have to go and get it again. All right.
You can cache it with the whole statue.
But let's say, like this example you're going for, you're chasing a new car. It's his car. You haven't seen him before since last week. And you need so there's a lot of you're pulling back new data.
Right. The dynamic content is really you should do it without a block, like asynchronous call.
Asynchronous call?
Yeah. But even asynchronous call, like you will block a UI, it's not good, right? So asynchronous call, but if no data coming back, you have to render somehow with some default data.
You have to, some default data. Yeah. No, these are all great things. Go ahead.
You may also need to pay attention to the data model. You don't necessarily want to bring a whole large object tree back in one call if you're going to be in a scenario where you drop connection. So bring it back in, which in a lot of applications, that's what we do. Try to bring everything back.
Right. That's the idea of RESTful. Some way you want to bring back the whole tree.
Yeah, you don't want to do that in this scenario. So at least you got the important information up front. No requests.
Right.
Yeah, how you order to get the skeleton first and then fill in the tree.
That's the tricky part.
That seems how Google Maps tends to work. You get the big road that fills in
the part is the root of that tree that we don't have that.
In this case,
right.
If you were just looking at license plates and you just took like the first character or the first 3 characters, just sent that when it was available, and just for people in the local area, you might be able to filter out cars that definitely weren't on the list.
Right.
With less data, you could say like, oh, I know that WXZ, if we don't have
But I mean, you need a connection to know of that.
Right, but you could like when you do that connection.
Be there sometimes.
Sometimes it'll
right.
be there, and then
In this scenario,
You got the connection, I mean,
you got timeout problems too.
well, in this scenario, it's more likely you have 4G, 3G, no G for a while, and then you come back to a 3G, 4G scenario. It's not, yeah. And so you want, like Greg was saying, if you have a request, let's just talk about reads and not updates. If you have a request that's long running, you're going to time out all the time, potentially, you know. And so you want to keep it maybe short spurts so that if you have a connection, go get it fast because I may not have a connection in 2 seconds. So that's the thought process I went through, and all the things everyone mentioned here. Some things were new. I haven't thought of those things, but others I have, and I think it's.
How about some kind of prediction mechanism so you know to locally cache? Say you're in like Loudoun County, right?
Yeah.
Then as soon as you hit it, whether you have as soon as you have a connection, locally cache all the places in Loudoun County. So
All right.
always have like some kind of smart predictive caching going.
So get all the data while you have the connection, and then while it's local storage, you could weed through it or just
but it has to be
filter
like
out.
extremely contextual, right?
Smart API.
Smart API.
API is smart.
Yeah. And I guess, yeah, it depends on the application if you could do that. Yeah, that's a good idea. All right, so I'll just to continue on. So I came out with 2 solutions with help from others as well. Actually, well, even before that, I thought of, I separated the idea to, do we have the server pushing data to the client? So the server is aware, okay, I've finished this. Is the client there? And like we were talking about before, Socket.io or WebSockets, could I use Pusher.com for that? We had mentioned that. Rails live streaming. I don't know anyone know about Rails live streaming? No. Okay, so it was new, I think, in Rails 4, and that's another maybe way of publishing, a way of sort of publish, subscribe, publishing the data when you get it. I didn't go down those paths, but I thought of those. Should the client keep reaching out, polling? We talked about that when a connection is available. Do I use jQuery, Socket.io? Maybe I'm going out to a socket and saying, can I get it again? So I identified and created a proof of concept for 2 solutions. But I know there are many others, like everyone mentioned here. So the proof of concept environment, you could start with any environment, .NET, Python, Django. I started with a Rails 4 environment. And I'll come back to that first comment. And then I used Angularjs, currently 1.x, although I know 2.0 is out in draft form right now. Postgres, and I started with an empty Rails Angular project. I had trouble looking into this. We were talking about this today. Where do you start if you want to do a Rails and Angular project? Do you use Yeoman and generate it, or do you find some GitHub project that has the template? So I started with this one. I use references here. I'm sharing these slides. We'll share after at the meetup on the meetup site. And the idea was, the last bullet point, that let me just create something very simple to prove this scenario. So typically, if I have this app, I'm going to collect, I may need to make 10 API calls. I'm just using 10 because it's an easy number, to get data. Let's just talk about gets. So I need to go to my server, and it's going to get this amount of data, and then do that 9 more times. And so on my server, I'm going to sleep for n number of seconds to show that it's doing some work. Ideally, I would use IO-based implementation. I would go to the database and do something there, but for simplicity, I just have a sleep. And I'm only talking about get scenario, although the application will do updates as well. So when I started this, I said, if I'm going to make 10 API calls on my Rails server, doesn't Rails do multiprocessing or multi-threading? Does anyone know about Rails multiprocessing or multi-threading? Anyone? Okay. You sound like you're about to speak up. Either one. Anyone? So I posed this question to Stack Overflow and got a lot of upvotes because I think a lot of people have the same question. How many people, just show of hands, use Rails, have used Rails? Okay. So we like Rails a lot around here, and I think it's a great environment architecture framework to implement applications, web applications. But in Rails, at least the MRI version, which is the C version, right? It's the standard version that you download. The Ruby, I'm sorry, Ruby, is not multi-threaded by default, and there's a lot of details in there. So I was able to investigate through the Stack Overflow question a lot of other research. So I'm just going to leave this here as a point. If anyone's interested, they could look at that posting. Okay, and so the first option, Angularjs retries HTTP calls using an interceptor when there is a connection timeout. So when you get a connection, if you're doing HTTP and you get a connection timeout, the status coming back is a 0. Who knew that? Nobody. Okay, I didn't know that either. Which means connect timeout, as opposed to 500, which is an error or something like that.
0 means good.
0, yeah. This is yeah. Whoever wrote this. The pros is it works, at least for retrieval. So essentially, I'm doing polling. You know, did this work? No. I got a timeout. Let me retry that. Let me retry that. Let me retry that. So it's simple, but it's not the best. So let's take a look at the code. Anyone have any thoughts on that before I see code? You see code? No. Okay, I don't want to see code. All right, let me make this a little bigger here. Oh, that's not. So for those of you who are not familiar with Ruby on Rails, I'll give you the 5-second primer here. So hopefully you're familiar with Model View Controller. So in this proof of concept app, Rails is the server, and in Rails there are controllers, which this is a controller, and my view is actually Angular, which has its own MVC component or MVVM, right? Component to it. So here, this is, imagine a RESTful call, and this is defined as API call, and I'm taking in a parameter of t. Can everyone see that? Mm-hmm. I'm taking a parameter of t, and if I don't pass it in, it's 60 seconds. Okay. So then I want to sleep for that time period, and when it's done, I'll render some JSON that it's completed. Okay. In Angular, how many people have used Angular? Show of hands. Okay. So let me make this a little smaller here. So in Angular, we define, if you're familiar with struts or familiar with any kind of configuration management tool that specifies your MVC paths, this is equivalent. So in Angular, what I'm doing here is I'm saying if I go to my option 1, then I will use this controller in this HTML page. It's a very basic thing that I'm just going to call this API 10 times, waiting 10 seconds. So I'm going to make the call 10 times immediately. So Rails, what should happen is Rails should pick that up one at a time. If it's multi-threaded or multi-process, maybe it handles it together. And then when it returns, when it's done, it'll update the UI saying I'm completed. So I don't have to go through too much of this, but option 1 just says, if you're familiar with JavaScript, I'm going to loop through this 10 times, and then on success, I will update the result. What I do have here is, and if I'm going too fast, just pause me here. So what I do have here is, what in Angular you could provide what's called an interceptor. So this is really a catch-all. Every time I make an HTTP request, it will come back through here. So I want to do that because, why do I want to do that? Anyone? Exactly. If I see the response is 0, then I want to retry after a second. That's what this $sign timeout says. So I'll wait a second because, and obviously this is a very simple proof of concept. In the real app, maybe I wait 5 seconds. Maybe I don't wait any time at all for a connection. And then I retry my HTTP call. I retry my RESTful API. So let's take a look at that.
Just a retry one time.
It'll keep on going. It'll keep on going. so the retry, it'll hit the interceptor every time it comes back. It's a, not connected, retry,
right.
not connected, retry.
Right.
So there's an issue maybe there of, let's say you're not getting a connection, or you want to try a different, you're following a different car. How does that work? So here's option one. So before I run this, everyone's familiar with Chrome and the Devtools. Hopefully, anyone not familiar? I'll ask them the negative side here. So Chrome Devtools is great. So I'm going to simulate with this this little thing here. I could simulate different devices, and I could also simulate, most important for this presentation, I could simulate what the connection is. So I'm going to say there's no throttling on the connection, and I will, actually I need to, a minor, sorry, 127. Thank you. I'm starting with Unicorn, which is a multi-process Rails server. So I was experimenting with that. There's also many others. So here I'm starting these API calls. So in my multi-process, it's actually going to go 4 at a time. All of the calls have been made, as you can see below. So you can see that down below. But now they're completed. And so what I'm going to do is I'm going to say I'm offline. So now I'm offline. I have no connection. And I'm just going to bring this up. You can see that the 4 were completed, and these are all started. But if I raise this, all these red things are saying, well, every second it's trying those 6 others, but it's just failing and redoing a reget. And so then,
eventually it could get the CPU, like chew up the CPU.
Yeah, so I don't know the solution to that problem, right? So, yes. You could exponentially do, that's a good idea. I didn't think of that. So yeah, you could exponentially set the timeout so it's 1 second, 2, 3.
Or you could defer to like just check we have as for all data.
That's right. That's right. Just do a ping or just do some very basic call or just, I guess, could you check for a connection without doing a call?
You can do a single tiny call.
A single tiny call.
You can make one request, and if that works,
then do the others. Right. I'll just do a head request. That's true. Yeah, so I didn't do any of that. That's great. And by the way, this is all on a GitHub account, which you'll see, and feel free to try it, fork it, and add to it. So then I bring this back online, and hopefully in front of all of you this works. So now it's in black here, not red, and it's going to get the data, right? It's pending. Hopefully, I don't know if I can make this larger, but, and hopefully after 10 seconds, there we go. 4 of them, because it does 4 at a time. I have 4 cores, so it's multi-process, so it's doing all 4 cores. And then the other 2, 10 seconds later. All right, so good solution or not? Works? No? Yeah?
We thought about, you probably have a later way kind of service solution like Node and event-driven.
Right, so a Node solution, so I thought of this. I said, well, I should use Node, right? Everyone's using Node. The mean stack. I love the mean stack. But I couldn't figure out what the advantage would be.
You wouldn't have to have much multiple processes.
Oh, yeah. So the whole multi-process, multi-threaded Rails was a side issue. I was thinking, because I know we've been at this, we've been at mean meetups and all that. And Node does have an advantage of non-blocking I/O. In this particular case, I think it's not helpful just from but it's sort of interesting how Rails deals with multi-threading versus Node. But who can see the problem with this?
Also, like from client side and server side, because of if you continue offline, it will continue sending the request, right?
Yeah.
And then once it's coming up, all the requests is going high up on the server.
Yeah. So what's the solution to that?
So that's why the smart API I was thinking about, like on the server side, you need to implement an API, which depends on the bandwidth of somewhat accumulate, right? The connection from the client side and to decide how much data to send. So you can respond or just kill the request. Something like that, right?
So could the server has to know the connection, the client's connection. Can the server know the client's connection?
Yeah, based on session ID.
And it knows whether what's the bandwidth is.
Right.
Well, for every you transfer, you get the bytes.
Yeah, actually, I think that
the time and figure out what the bandwidth is for each cat.
Right.
Right.
That's true.
With the REST API, there is a API gateway from CA, Computer Associates.
Okay.
They actually have an API qualitative service management.
Okay.
You don't even need a code. You can basically tweak the REST API interface.
Okay, that's good stuff. I didn't think of that. I wasn't thinking that complex, right? Because with these solutions, it's I guess you can make it generic, but
well, it's which layer you choose to solve the problem. If it's the protocol or the method using REST or something that's more reliable.
Right. No, true. All good points. So let me show you the next place where I went to, because
what do you think the problem is?
Well, the problem with this is there's two problems with this. One is that after I set it to no throttling, it had to go make that server call again. So let's say I was 90% done with the server call before I shut off the connection. I now have to redo that server call, and that maybe I have this like intermittent connection where it's only available for like a split second or not a split second, but let's say 2 seconds every minute. So it's never going to work in that scenario, right? Because I'll never complete that server request. Now, as was mentioned before, if I had smaller, this is waiting 10 seconds, which is artificial. If I had smaller chunks of data, that would be better. The other problem with the solution is that updates. What happens if an update fails? How do you know? I mean, the client, right? I sent the data. Wait, do I want to retry that? Is that, am I going to get, what's going to happen there? The client sending, the server sending acknowledgement to the client, or?
Who's getting updated?
So the client is updating the server. Just let's say a simple CRUD operation, a simple update operation from the client. How do you know if I lost the connection? I guess if I lost the connection, I retry. But is there any case where the connection could be lost?
That's you really get to the message queuing.
But the server has done the operation.
It's actually more about inserts then, because on the insert, you're not really sure if that failed in transit or if you just get a response from the server.
Right.
So on inserts, you would want to some way check whether you have already inserted that.
Yeah.
Those are usually answers.
Right. So inserts, you're absolutely right. It's a better scenario.
When you want some kind of incremental session key, where you're basically saying, you can have as many GET requests as you want. So say this is GET request number 500, but on update request, you can say this is update request number 4, and then you can say, what was the last thing in the process?
All right. So
or
like
the payload is part of the next request that you get. If you come back and say, hey, I see you asked for update 501, but by the way, update 4 is finished.
Yeah, that's
Or
good.
I accepted it. Or you could say update 3, and you go, oh, I know update 4 didn't work.
Yeah, that's good.
This is what the message queuing, like the MQ type of idea.
I remember MQ from.
That's all you do the persistence and the transaction,
right? Right. No guaranteed delivery.
Yeah.
So let me go back to here. Hopefully this works again.
What do you deal with the second time on?
Good thing with message.
Right. Well,
the good thing with message queuing is that you can have some intelligent algorithm on either side that reevaluates it while it's waiting.
Right.
Eliminates some potential.
That's right. And then session timer, we're not dealing with sessions here. There's it's Angular to separation. So separation of concern. So option 2, similar to option 1 with retrying from the client, but let's also save the response to the server, so we don't have to do the work again. Right. So it's similar and you guys mentioned IDs and coming back and checking. So obviously, this is just a very basic proof of concept, but it's the start of that. It's certainly we're thinking the same thing. So it also works with retrieval updates, inserts. You could have longer running server processes without the word. So you could be connected to go do your work, and you lose the connection on the client, and then you come back and say, wait a second, I'm back. And the server could say, oh yeah, I already finished a while ago, here you go. That's exactly what we want, right? There's issues with this, but right, so any thoughts before you see the code?
So the requesting in between the dead connection and it coming back.
Well, you have to know that you have to associate every API with an ID, right? So you have to say, here's my ID that I made the request with so I can match it up on the server. And so you have to have a unique ID for that API. You have to be known who is the client, right? So whether it's a session ID or some other transaction ID, right? You need the combination of either a globally unique transaction ID or some ID plus a unique session ID or something like that.
So if you have 1,000 clients, depending on all of them to generate the ID.
Well, as I said, if it's a concatenation of, if they all have unique session IDs. True?
What session ID?
What's a session ID?
No, what session ID do they have? Because they've already previously connected to the
yeah.
Solution requires you to have an ID generated on the server side.
That's right. Right. So the first time, exactly, the first time you're logging, I mean, assuming most apps, although we've done an app recently where there was no login, it was a registration portal, but most apps have a login, so you're doing some handshake.
Okay.
So, but all great points. I did the session ID because it was easy, but there are many implications, right? There's security implications of hijacking the session. There's all these different scenarios. Okay, so let's see the code. So with option 2, it's exactly the same. I think this is pretty much the same, except I'm passing in, I'm making the current time and some integer as my unique ID. Obviously, this is done quickly. It works, but you probably want to go a little deeper than that. That's my unique ID. On the server side, you have, it's a little more complicated, right? So I'll explain this for those who are not familiar with Ruby. Again, I'm passing in t as a parameter for the time. If it's not passed in, it's 60 seconds. I'm passing in the ID, the API, the ID that's associated with the client request. Is this a retry or not? Is this the second time I'm through, or is this second or more, or is this the first time? And then if I am, well, let's skip down to here. So I sleep the same 10 seconds, and when it's done, I save my result in a database. So this is Rails, so save result. It's going to work. I have a model here. It's just called my response model that just says, I'm just going to create an entry in a database table that has 2 fields, the API ID and the result. Again, very simple implementation. Maybe you would use Redis, maybe you would use something else, but this stores the response so that you're not doing the response again. So if I come back to the controller, then when I retry, I say, hey, wait a second, let me look up that response by the ID. And if I find it, I'll just return it. And then I think I'm saving, somewhere here, I think I have a session ID. Yeah, I'm saving the concatenation of the session ID and some time thing, current time from the client. Again, not the best, but it doesn't work with, maybe really quick calls. Okay, so let's see what that looks like. If I go to my option 2 here, I will.
Can we see your code? Is it exactly the same?
Yeah, let me start this. I'll come back to that, definitely. So this is similar starting. I'll go offline. And now let's just wait more than 10 seconds. So what should happen when I go back online? If I've waited more than 10 seconds, anyone?
Immediate.
And they get a free shirt for this.
Before request started, then that
Exactly. So the four of the requests that started should end immediately. Well, relatively immediately it does the call. The other two, because I only have 4 core I'm running, the other two should go back.
Save just a cache. You're not saving like external database.
I'm saving it to a Postgres database on my server. So as a yeah. So if I go back, it did all. It does all 6 because I waited long enough for the threads to the processes, 2 more processes to run, because it had already made all 10 at the beginning. Yeah, even I thought I was with you too. I thought it was going to be 4.
I didn't think it started all.
Yeah, it did. It starts all 10 because right, it's typical web app. You want to go out. So this is just showing result from the database. This was the actual JavaScript time object, and this was API 5, 6, 7, 8, 9, 10. Right. So good, bad, not. I don't know. I think it's pretty good. Better. I like some of the ideas though. I want to.
But you do have the I/O, so if you save it, like if you have lots of requests like this, you save the response in the database.
Yeah.
You potentially have some I/O operation.
Yeah. So.
Potentially.
What do you mean? Too many saving? Oh, but
Yeah,
while you're saving?
Yeah, too many saving.
Oh, well, inserts hopefully are quicker. Maybe you offload those. Maybe you offload those to a job that's a separate process. Maybe use Node, and you're not waiting as much with MongoDB. Yeah.
This assumes that your request from the client is then you lose the connection, right?
Yes.
But if you get the connection back again, now you're making another request and the server hasn't had time to finish the first one?
Yes. If the server hasn't had enough time to finish it, you'll wait.
Right, but it may not be something that you can run again, and running again might cause an error for this. Or say if it's an insert, right? Like if you have multi-threaded server.
Right.
One thread is still running the insert.
Right.
And you get another request, it finishes it, but the second request has already started.
Well, so in the code, and I think I get what you're saying, but let me just see if I may not. But in the code, I don't save it to the database until. Oh, I see. Right. Yeah. So in that case, yeah, this code has to be improved. That you know that it's already in process. It's already being processed. Great point. Excellent point. Yeah. All right, because it's the same key. So maybe that's how you handle the duplication. Maybe not. Yeah. So
this is a classic race condition, right?
Yeah. It's right. So good point. Good solution. So let me just finish off here and then. Whoops, I went too far. Sorry. So okay. So last slide. So retrying after n seconds, like I mentioned, is it n seconds? Is it? I like the solution of you progressively get more and more time. Option 1: can we kill the server request if the client goes away? Does that matter? Do we care about that? I don't know.
It depends on the business.
Depends on the business, exactly. Option 2: when do we delete the data? When does it become stale? So I'm now a month later going to get something. Well, not a month later. Maybe it's the connection is gone for 10 minutes. I'm in a tunnel and I've had to deal with an accident, and now I'm coming out of the tunnel and it starts again. But maybe I care that 10 minutes has passed. I don't know. Maybe when do we delete the data just in general? I'm storing everything in the database. If it went back to the client, does the client now send a new request saying delete me? Or do I just cycle through the data and delete it every couple minutes? Right? I don't have an answer. I'm just saying with all things. Mobile, we brought up mobile app versus web app. Is there issues there? I don't know. Is there differences there? To improve in general, gzip or minification of, if you're dealing with low bandwidth or missing connections, especially low bandwidth, you want to improve the experience by zipping up everything or minification, JS files, CSS. I actually tried to do this on Heroku, and it didn't work because on Heroku there's a request timeout. So every time I was trying this proof of concept, I get 500 errors because it has a 30-second timeout, and I was hitting that all the time. So then I just decided just to do it locally. I did it locally with localhost, but with the Chrome tools, I couldn't throttle the connection. And then after about a half an hour of research, I realized that all I needed to do was do 127.0.0.1, and it figures out that that's, I'm going through, at least I'm not bypassing that connection. So as I said, the GitHub account, the GitHub project is out there if you want to take a look at it. And we actually have someone who emailed us, Josh, who said, hey, I've worked on a project where we had the same situation, same scenario, or not the police part, but the limited bandwidth part. So any comments from this before Josh comes up?
I was going to say one other aspect is you've got in addition to local storage, you have just the browser. So if it's the same URL, something you retrieved before, it can resolve depending on how you structure the URL immediately by the cache, as long as it's in that outdated stale data.
Right. Yeah, local storage. Yeah.
But not even local storage,
just browser cache. Yeah. Yeah. No, agreed. Yeah.
Other scenarios for this is like when you go turn your phone onto airplane mode and then get in flight, and then you have limited bandwidth there.
Right.
Taking a long time. You have that.
That's a great point. Yeah. No, that's a great scenario. Yeah.
And I think you can eliminate the retries if you use promises. If you use the promise that said, okay, let me know when the connection comes back.
Oh, right. Just do like an HTTP head call or
Well, I guess a promise is a little different because even with the HTTP head call, you have to hold.
Right.
I'm guessing, but I'm almost sure there's a disconnection available promise.
Okay. In Angular or just in
JavaScript and probably in Angular. Okay. Because have you noticed Chrome when you go offline, when it comes online, you say it automatically refreshes your page.
Right.
Well, back then you have to
So it's using some sort of promise to do that.
Oh.
Yeah.
So this whole concept of offline online issue, right? I mean, it's a kind of global or at least generic issue now, at least by now.
Right.
I'm sure a lot of people go through this. Did you come across any generic framework or library which deals with maybe some JavaScript library, which, I mean, a couple of concepts I can derive, retry and unique client ID, things like that. Maybe somebody out there in the GitHub, maybe they already did something.
I did see a jQuery plugin for the standard AJAX call that gave you a retry option, normal, similar to when you say post or get, and it said retry, and it was a number of times, and I think it had a wait in there as well. That essentially implemented what I did in Angular.
What I found actually is it's really hard to find frameworks that deal with those kind of situations. Most people, talked about the first world and really high connectivity situations.
Yeah.
So in my experience, it's actually quite difficult to find those types of libraries. You can use member data out of the box.
Oh, it does that automatically.
Well, yes.
So, yeah.
As long as you just define your model and it expects your REST API to have a certain.
Okay.
So what is the data?
Member data.
All right, Josh, you want to come up? So we're just going to transition for a second. If anyone wants to take a quick break.
I have an older one, so.
Okay. How about? There we go. Hey, look at that. We need to. Let me see here. This can work.
Please take this time to go grab some refreshments.
Is Joel out there?
Yeah, he's great.
Did you want to do the Prezi thing? Or sorry, the
join me. If you go on joinme.com/street1. He's got an old.
I think it's cable. Remember, how old is it?
All right. But I don't have the.
That's what I mean. We'll have to run the cable over. So is the DVI one on down
There
there?
was, oh, here it is.
Yeah, try that first. Oh, no, I don't have one. No, there should be a DVI to a mini DVI. No, it's just all VGA. No? Okay. Give me one. Okay. Sorry, I'll upgrade next year, I promise.
Okay, solution sheet one. Oh, it's right there. This is public.
What is that password?
I'm sorry.
No, so I turn it off and on. VGA to mini DV.
Can't get connected. What's the street? 5-4.
Street 5454. Just type in ours.
Yeah.
Three, two, one. That's what I hear. There we go. Let's log off the Skype.
There we go. Your viewer two. Going to be fast presentable to you.
And then we're going to start something.
Okay. 3%.
It's like they have a street.
You are.
I've lost my mouse. There it is.
Oh, you have to do a page. You have to go to screens, and you're probably mirroring screens this way. Go to system preferences, displays. Oh yeah, go to a Mac. No, next one. System preferences, display. Just scroll. There's no mirroring. Hold on a second. Hey, Joel. You're good with that. No, what he can't see on his screen on his computer.
Mirror arrangement.
There we go. Mirror display.
And you can probably get at least 1024, 768, or maybe 12.
Okay, that's about it. My boys, Caius and Galen. Okay, so I'm just going to present a case study, I guess. So we dealt with a limited connectivity situation before. It kind of comes up in our international work a lot. I'll get to that, I guess. So the program that I mostly work with is called Tangerine, and it's an Android application. Oh, sorry, this is the outline. This is what I'm going to be doing. So I'm going to talk a little bit about what Tangerine is, where we were at the time and what we were doing, what went wrong, how did we respond to what went wrong, and then I guess some Q&A, but didn't realize we have more of a fluid structure than that. So if you feel like chiming in at any time, please just feel free to just say something. So what is Tangerine? It's an Android application. It's primarily used for data collection. And the type of data that we're interested in is literacy assessments in early grades. So 0 to 3, or sorry, 1 to 3. There's two parts to Tangerine, basically. We have a web interface for designing assessments. Researchers will go online, they'll design their assessments, and they download an APK. They install that on all of their tablets, and then the mobile interface is used for collecting data. So people will hire enumerators to go out to different schools and to test children on some random letters and words and things like that. The assessment was developed by the NGO that I work for, RTI. It's called the Early Grade Reading Assessment. So it's a nice scientifically rigorous way to capture literacy data on the grades. The technology behind it, it's a web application, primarily written in Backbone.js because I like light frameworks. Angular is great too. Just gonna say that. No more Backbone is basically a wrapper for jQuery, in case anybody doesn't know. It's very lightweight. It gives you controllers, a router, which is basically a router, models for some basic persistence calls, views for updating the screen, and then collections of models that you can batch fetch. That's basically it. It's just a way to organize your code. It's nice. I like it. Been looking at &JS recently, though, and that's even more minimalistic. We package all that up using Apache Cordova, and that basically takes a web application, takes all of your JS, HTML, CSS files, and images, and puts it together in a directory and installs it as, you can make an APK, and it installs that, and then when you open up the application, it basically points to your index.html file and then serves that up for. So it looks like an Android native application, except that it's like a web interface and all that. So you need to define your own interface basically. And we use Couchdb, and that was something I inherited. It's a document-oriented database. I don't know if anybody's used it. Show of hands. Couchdb. All right. Did you like it? Love it? Hate it?
I kind of liked it.
Yeah.
It was the first kind of
okay.
documentation.
Yeah. Right. What did you use it for?
It was an internal application.
Okay. Cool. Nice. So yeah, it's a document-oriented database. It saves JSON objects. That's it, basically. And the way you access the data is that you write a function that parses the JSON object and then gives you a key and a value. And that's called a view in Couchdb lingo. And then you can query the database like you would any other key value store once you reference that view. So it's good for some things, it's bad for other things. But it gives you a schema-less database that you can store anything you want to. It's very flexible, and it's very simple. You can have what's called a couch app, all served with Couchdb and using Couchdb. So it's interesting. Okay, so a little bit about the, this is a case study, so a little bit about the context that we were working in. This is a rasterized version of Kenya's flag, which is where we were. The context was rural. We have tablets, so all these. So the Tangerine application is this Cordova web app running on Nexus 7 tablets. They're distributed all throughout the country, and a lot of them are very rural places with limited connectivity. So normally we also send them out with these little routers, these little portable routers, and a little USB dongle. That they use to get cell service, so they get data that way. But it's a poor cell connection usually, which means we have an intermittent connection and low bandwidth basically. Because we're not talking about 0G, 3G, 4G. We're talking about 2G, 1G, or we hope,
2400 baud.
Exactly. That's what we're really looking at. So that's been a lot of fun. And we've dealt with these situations before, so we've already made some adjustments, some tweaks to Couchdb. So we, set all the timeouts and retries to maximum, whatever we can think of. But when we finally had to rely on people actually just staying there with these little dongles and trying their best, because they're not going to be able to get to an internet cafe in town anytime soon, and we kind of wanted their data very frequently. We had to kind of just deal with these poor connections. So the problem, this giraffe is 800 feet tall. The first problem is this giraffe is not to scale. This is Kenya. So the users complained that it didn't work. This was what we first encountered. What that meant was that there were a lot of timeouts. Basically, they would send requests to the server. The application is structured in a way that once they go and they collect their data, everything is stored on the Couchdb database on the tablet. And one reason we like that is because Couchdb can do master-to-master replications, and that just made it really easy for all of our networking. We just basically made a call to the database, said replicate from this database to that database out on our server, and that handled everything. There's a lot of black box stuff going on underneath. I'll get to that later. It gets tricky. The request just didn't finish. We would see it on the server. The request would come in, and we would see it start to become active. There are a couple of small requests that it makes first, and then it wouldn't finish. We would just see it drop off, and it would never. That's all the logs showed. And it didn't give the user any feedback. That was kind of one of the big things that was sort of easy to implement that we used to fix it. So it's a different situation in your case. Your case was, the police officers needed the data right away because they're in hot pursuit or something like that. In our case, it was more like they were sitting around and waiting for it to finish uploading their data because they're getting paid by the amount of observations they upload. So they would sit there and wait, and wait. And the connection would come in, drop out, a cloud would roll by, and everything would stop. So. I guess I could, why don't I just ask for suggestions? Yours was set up a little bit different, so maybe it was a little bit more amenable. There were a little bit more details, but if anybody feels like offering any suggestions, how would you fix this in this case? It's a little vague, I know, but.
You probably use the database replication to not because of your API problem on both.
It was both, actually, I think. Yeah, I think we can say both. So Couchdb does, its replication model. It uses multi-version concurrency control, MVCC, to take care of different versions of a document and different So when they sync, when it syncs them together, it checks to make sure that it's not doing any kind of overwriting of any data, or it's and as well as that, it's checking to make sure that it's not trying to sync anything that has already previously synced. But it does that in a really it just does a lot of calls in the background. They're all HTTP requests, but it's setting up like it's setting up like small. He's cringing in the background there. It's doing multiple HTTP requests in the background. So that's one thing, and that's actually one of the steps was to get rid of the Couchdb replication for our case, right? Because we're not talking about editing in two places. And, you know, we want to make sure that we don't overwrite any changes. We're talking about new documents generated on the client, and then we're uploading those. So that was our one of our first steps.
Yeah. You could break up, you know, each document result as a number of, you know, either multiple updates, but if one is just one update. So let's say you had 30 responses that you had to upload, right, and you get a connection for just a couple of seconds. You can update, you know, 1 or 2 or 3, right, and, you know, at least you're part of the way done.
Yeah, exactly.
You have each of the Couchdb databases when you're initializing the app, have them register to get a unique key with the server, then that's effectively your session for that application, so that it doesn't matter what the keys are on the database, it's still going to be unique when you pass the application. Right, exactly. Yeah. You guys are 2 for 2 so far. That's great.
Pretend that it uploaded.
Yep, there we go. So no feedback, right? Just put positive feedback all the time.
Well, it's going to eventually upload if you're worried about people just sitting around for hours trying to upload. It's going to eventually happen anyway once they get connectivity. Right. You could just say like, yes, right, it's stored locally. It'll get updated.
Yeah.
It's a line though.
Yeah.
It's a line.
You can do that without line though. You can say, this is what you generated, like this is the amount of value in terms of the number of responses you have. Like you earned $60.
So you can
just say,
right. Upload.
You will get paid for this.
Eventually.
Yeah. I mean, I guess you could do a checksum of that. You could say, hey,
yeah, we could.
This problem isn't, I mean, you know, like NASA deals with this kind of problem. We're talking about something going to do
right,
like that,
right,
where, you know, your message going through, you're not really quite sure it's going to get there, but latency is going to figure out what it is.
Acknowledge.
The web.
Right, the TCP and acknowledge, right?
They had a redesign in articles I've read about that. They had a redesign TCP.
Well, that's what I'm saying. If you're trying to use normally TCP IP for unreliable passport, you should drill a hole in your head.
Yeah. Yeah, it is.
But it's fun.
Well, it's a hard problem, isn't it?
I mean, easy problem.
Yeah.
You could use something like
Yeah.
like you could buffer it.
Or message pack or something like that.
Have a dynamic buffer setting.
Right.
You could have set up some kind of localized server in Kenya where it would get to faster than translate to you guys.
Yeah.
More reliable connection.
Yeah, we thought about that too. The problem was there was no connectivity anywhere until you got like some connectivity. There's no like partial solution that we could implement with like a.
Was this just working on the internet?
That's okay.
Put a server on there.
Yeah, exactly.
It wasn't spotty, it was just complete honor.
Well, no, it was spotty. Yeah, but I mean, it was more unreliable than it was reliable. Like he said, you know, you just want to drill a hole in your head.
You tried climbing a tree?
You know, we do give recommendations for the GPS signal, because that can be really flaky, and they are collecting GPS data to keep them honest, basically.
What were you using for the radio, or what wavelengths were you using?
I don't know. You mean for the phone dongle thing?
Yeah, the communication network.
Yeah.
Using just the airwaves. You shortwave?
Oh no, it was just using the cell signal.
GSM.
Yeah, GSM. Yeah.
Okay. How much data was actually uploaded?
Let's see, about. There's a lot of questions in there, and it's all stored in JSON. Plus, there's a bunch of other information packaged in there as well, like paradata and metadata. So it ended up being something like I think it was 30K for one result, which was tons of questions answered.
So it stored the questions and answers in the data.
Yeah.
The one is just to like upload the questions separately, it'll be the same roughly. I would expect.
Right.
Just
Exactly. The thing is, the assessments in our case change quite frequently, just because of the nature of the type deadlines that they are working with. They need to adapt these surveys up until the last minute until they make the APK. So.
What if you do 10? 10 kids in the room.
Yeah.
They do all 10. You only need to upload.
Yeah, that's true.
And the questions could be version controlled as well, right? The version control database. So
right.
The version of the metadata.
You could send a hash and it doesn't change.
Right. The thing about that is Couchdb doesn't recommend that you actually use the different versions. They only use it internally to make sure that the replication takes place properly. They actually recommend that you develop your own versioning system if you're going to be going back. Yeah. It's kind of lame, right? I mean, they open this up to you, and they give you a peek, but it's not reliable.
So I'm a little bit curious. When you said you get rid of the database, that should improve you quite a bit, right? Because the majority of traffic is really the replication traffic.
Yeah, exactly.
Some unnecessary because
you
just do the insert and
exactly.
coming back to check.
Exactly.
So that should reduce at least like 80% of congestion.
It did quite a bit. Yeah. Thing is, we needed to. Okay. Anyways, shall we go ahead and so I do the big reveal? Okay. Step 1 or 0, geography. We moved our servers, which reduced latency, which was one of the first steps that we did. We went from New York to Frankfurt. And since we were still on the replication at the time, reducing the latency made a huge difference for us. But still not enough, because there was, for the reasons that I'll talk about in a second. Step 1, divide and conquer. Who said break up the data into logical chunks? Yes, there you go, gold star. So we sent groups of documents that were going to be joined on the server for the reports anyway. So this was sort of like the minimum amount of data that we could send that would make sense, that we could generate a report from. And then if at first you don't succeed, try again. Basically, we just kept trying to send it over and over and over until it worked. And that, a lot of the time, made it much more reliable. It's really kind of surprising the amount of success that we had after that. But again, we're reinventing the wheel, right? We're trying to do something that TCP wasn't meant to do. No. Step 2 was psychology. We told them exactly what was happening, and it eliminated so much user concern. We displayed 3 pieces of information to them. We told them how the upload was going, that they had done 1 chunk out of 15 chunks. We broke that into a percentage.
And then tell them chunk 2 will take this amount of time, so you'll get a couple.
Yeah, exactly. That was the second one. We said their internet connection. Your internet connection is horrible. Yeah. Exactly. Yeah. And then we told them how their uploads had gone previously.
What was your best connection? Like bandwidth-wise?
Bandwidth-wise, it was like 3G. Just like a regular 3G. That means that they were sitting in an internet cafe and they had access to the Wi-Fi or something like that.
What did you use?
Boomerang. It's by Yahoo. They have a really nice JavaScript bandwidth and latency measuring tool. And so we put that right on the screen, right in front and center, and said, this is how your internet connection is doing. Step 3, LZ compression. We compress the data. Yeah, I bet everybody was like, yeah, it's small, right? What was that? What's that?
LZ guys, the lawsuit with JPEG and all that.
No, I didn't hear what happened.
Well, yeah, it expired. It would have been like one of the biggest lawsuits in history, but the moratorium was it 25 years or 50 years? Usually 20 years. 20 years, something like that. So the patent expired. Otherwise, everybody has to pay royalty on JPEG.
Wow. JPEGs.
Oh, yeah. Oh, I saw decompression. Right.
Wow.
Unisys has a patent.
That's amazing.
Oh, GIF, I'm sorry.
Oh, that's right.
Yeah.
I think I did hear that, yeah. Who says GIF? Giraffes, yeah. Okay, so immediately, it was hard to find any compression that was built for JavaScript, right? We searched pretty high and low, and there were 5 or 6, actually, that were candidates that ended up not working in the browser because they were meant for Node instead. LZ string 133 is the one we use, and you'll find that if you Google LZ string, you'll find some weird blog post. That's the one. It works.
Did you guys, since you were using Cordova, you could actually write a custom plugin that could do stuff in Java.
Right. Yeah. That's true. That's yeah. Yeah. Probably. What was great about this was that we could decompress it on the server using Node at the same. So it was just one point of failure, I guess, removed. But that brought our JSON down to 38% of the original size. Can you believe that? So we barely had to transmit anything anymore. But of course, we can't send binary data through AJAX with a post request. At least we couldn't. You can do it. But for some reason, whenever we tried to encode it into binary, and we tried, there's a lot of different switches that you can use, that you can set on an XHR request that say this is binary data. You can set all the headers. Let's say this is binary data, the W, whatever, our binary application, the content type. We tried the appropriate content type. We tried all the appropriate switches. And it looked like what was going in is what was coming out. But there was some byte or some bit somewhere that we couldn't figure out. So we lost some of our efficiency, and we had to use base 64 instead of binary. So this is a hack, first and foremost. I want everybody to be clear. I want to be clear about all of that. And that limited that got us back up to 60% of the original size. So unfortunately, we're still sending more than we need to, efficiency-wise. So we ditched Couchdb replication, and we're just making a straight post request, or we're sending all of the data at once in chunks. So we're become quite a bit different. So the MVCC overhead that we were talking about earlier, that's no longer an issue. So all the multiple requests, that's gone. So yeah, the steps we went through was we changed the geography, we divided and conquered to send only chunks of data. We told people what was actually happening. We used LZ compression, and we did Couchdb replication, and that was all. I think all you guys suggested all of those changes. So well done. That's.
Did you try cell phone signal amplifiers?
No, with like a coffee can.
Devices.
Oh, you're kidding. Wow. Okay. Yeah, I'll write that down.
I have a buddy that sets up Wi-Fi for big events in remote locations. He has a lot of RF knowledge.
Yeah, I mean, you brought up the shortwave thing, and that's.
Yeah, there's all kinds of different things you can do in radio spectrum.
Yeah. Gamma rays, right?
Yep. Well, you can bounce.
Wave of the future. Oh, really?
Certain wavelengths bounce in that.
Right. Well, that's why they wave shortwave. Is that comes off the ionosphere, right? Yeah.
I think the interesting thing is Kenya is actually #1 leader in mobile financial transactions in the world, but nearly everything is going in through SMS. So
right.
If you had more than 160 characters, you could somehow try to run it through SMS, which is like super reliable.
Yeah.
Then try to get it.
Huh. SMS wasn't that reliable for us in Haiti. They have about 3 different carriers there that have trouble communicating with each other. Yeah, so if one person's on one network and our sending device is on another network, then that was an issue for us. It was sometimes reliable, sometimes not. But in Kenya, I don't know what the situation is like. It might be different.
Yeah, I think it's
yeah, I bet. A lot of places are better than Haiti in terms of internet and communications infrastructure. I'll be here if anybody wants to talk about anything else. So, thank you.
One more. Give us a second here. So can you change the presenter to?
Right.
Change. Oh, he's going to log in. Oh yeah, that one. Yeah. And then he's not on yet. Oh,
Correct.
he just. Yep. There you go. That's it.
Past presenter.
There you go. And then.
Oh, thank you.
How does that minimize?
Just the circle.
Yep. This one? Yep. That's not gonna. Oh, not gonna kill it. All right. So I met some of you, but my name is Greg Khodam. I'm a senior software developer here at Solution Street. We're actually going to switch gears a little bit for this presentation. This has nothing to do with mobile or limited bandwidth applications. In fact, it's actually architecting multiple Ruby on Rails applications that share a common code base. Again, a show of hands, how many folks have played with or used Rails or Ruby before? I know you have. Okay, so a few out there. How many of you have used other languages like Java, Enterprise Java? Okay, so I'm a Java guy by background for 10 years, and I've recently switched over to Ruby on Rails. So some of the problem sets that we would solve in Java in one way is very different in Ruby, and this is actually one case where I found just recently things are done a little bit differently in the Ruby on Rails world than what we would do in a traditional .NET or Enterprise Java kind of a framework. So the first step here is the business problem. Client wants you to build another, in this case, Ruby on Rails application that's really similar to one that you've already developed. They love your app, they love the functionality, but they want something a little different, right? So when we think about this as architects, we start to think already about components and reusing, right? We all want to dry our code up, reuse components. So we know our app has an admin component and has, a well-defined user model with roles and permissions and access control lists and a workflow engine, and we've got all that in there. But the business functionality is going to be slightly different in this new application. So this is a business problem I just recently had on a Ruby on Rails project that I'm working on. And again, I'm sort of new at Ruby on Rails. I've been doing this for 8 months now. So kind of came at this with my Java hat. Oh, this should be really easy. In Java, I'm gonna probably have some core component or core components where I have jar files that I'll bring into my application, define some base classes. I have my interfaces, right, and I can reuse and redefine, and that's great. It's a little different in Ruby. So again, some of my architecture goals, obviously we want to share the common functionality. Ideally, I'd like to reuse pieces of the MPC stack, so my controllers, my models, even my views if possible. I want the ability to easily customize, extend the common functionality. So again, with my Java hat, thinking about inheritance and interfaces and all those kinds of things. Minimize the maintenance. Again, I want one code base to maintain that admin component or the workflow component or what have you. And again, coming on the Ruby on Rails side or the Ruby way, everything's about drying up your code, right? You guys know what that is, but not as much. You don't hear as much of that in the Java side, but definitely on the Ruby side. So we really want to encourage drying your code up. Don't repeat yourself if you haven't heard that before. So those were my architecture goals for this. You guys probably have some other thoughts on that. Anything to share on just why I would reuse a component?
You kind of do dry up your code in Java with inheritance.
You do. Inheritance is definitely one way to do that. Sure. There's some tricks in Ruby too, or Rails that also encourage that. We'll see. So, solutions, and I have solutions with the question mark, because some are bad solutions here, some are good. The first one is, the all-in-one app, right? We don't really break this thing up. We had this one massive app in Rails, they call it, or the monorail. Which I thought was kind of cute. But we just cram all the functionality in there, and maybe it's even a software as a service where I turn on and turn off different functionalities. This is client Y, so he gets this part of the app, and we don't want to do that, right? But that actually, I've seen this all the time on projects, right? And it's one of those scenarios where you don't really intend to do that, but deadlines and budgets and so forth, that's kind of one way things go. The next level is a good solution. We start to think about service-orientation, breaking my application actually up into multiple applications, exposing the functionality of services, communicating between these components using REST, maybe web services, other protocols, and that's a really good solution. Has anybody done something like that before, where maybe you have your admin component that's managing users separate from your application component, either as a physical separate application or logically separated on your web server? Has anybody done that before? Yeah, okay. So there's some challenges there. You might be sharing the same database and may have some contention issues, some concurrency issues. But in general, it's a good solution. Some of the problems I had with it for my particular scenario was I really wanted to be able to get more granular in terms of my customization. So not only do I want a user, but for one of the applications, I might want a user, and I might want to also put his employee ID on that model. But my other application doesn't have that. I don't want to pollute my database with this, huge table with all these columns that don't mean anything to the other application. But it does serve its purpose in a lot of applications. Software as a service, that might be a good application of this. So the next thought was, okay, what about code level organization? So this is coming back to my Java days of having a core jar that contains some of my common functionality. I can put my models there. So it's really a reusable software component in Java. It's a jar. In Ruby or Ruby, actually, it's called a gem. It's just a way to package your software. Rails being more of an application framework, MVC, it has a component called a Rails engine, which is what I'm going to focus on in this presentation, which is really kind of neat. But the idea here was to keep separate code repositories, still keep things separate the concerns there for the projects, but be able to reuse this component within several of my applications. So those were my thoughts on this. Are there any other solutions or thoughts, or you guys ever dealt with this issue before on your projects for your clients? I'm sure it's a pretty common scenario, especially here at Solution Street. I mean, we have multiple customers, but we find ourselves, doing the same kinds of things for similar projects. Any thoughts on that?
So if you use like, sounds like you guys use Postgres, but you use HStore, for instance, like it's basically schemaless.
Okay, yeah, that's a good solution.
So
Yeah.
basically, you don't.
Yeah, so that would better address this problem. I don't have a defined schema necessarily, but it can have multiple apps. Right. Yeah, and that was the thought too, as I was going through this. Do I have a separate code repository for my common functionality? Do I include it, with the application so it's still one, Git repository or what have you? We decided to again go to the separate code repository, so it truly is standalone, and it does enforce in the developer, or helps reinforce in the developer's mind, this is really separate. I've got to think about what I'm putting in this repository, that it could be reused by other projects. So what we get, yeah.
It's interesting because I actually they had this app that had like about 100,000, 200,000 actually, and they had separated it logically to separate chunks, and they were communicating via API. Okay. But they were still like the same app, but two different workspaces, and what they actually ended up collapsing them almost into one app, then using Rails engine. Okay. Okay, great. Yep. So we decided to use Rails engine, or I decided to use Rails engine, and this was 2 weeks ago. So we actually just so things happen quick. You got to go through this, and this is timely for our presentation here. So yeah, so we use Rails. So a Rails engine is a Ruby gem, and again, a gem is just a way to package up reusable code or classes in Ruby and used by Rails applications. But the other important aspect of it is it's almost its own application. It has a full MVC stack in. In fact, it has the same directory structure as a normal Rails application. So if you're able to build that whole stack within this reusable component, which is really what was useful for us, and you'll see that there's a nice guide, but the Rails documentation is pretty good. There's a good guide on this, and actually what I'm going to go through now was from that tutorial, how to build an engine and how to bring it into an application. Kind of like a WAR file? Yeah, it's similar to WAR file, but it may have changed since the 8 months. But WAR file, you can't really extend one WAR file to another, right? That was always another problem with Java. You'd have to repackage it into a different WAR file, bring your jars in and all that. The nice thing about it is it's like an extendable WAR file. So I have a WAR, if I could do something like that, I have my WAR file, and I'm actually extending it in my application, so I don't have to repackage everything. So what the Rails engine allows me to do, we just mentioned, is I can extend, reuse the models, reuse control, the MVC stack, helpers, which is another component or concept in Rails. I can reuse assets, so I could actually. This is another problem I've had in Java before too. Defining with a jar, you don't really put JavaScript classes, but even in the WAR file, it's just all packaging. Here, I could actually package my JavaScript, CSS images into this engine, and again, reuse it easily in my application. Routes, which define URL paths and mapping to controllers. Rake task, which is similar to make kind of a concept, that type of scripting. Generators, initializers, which is more to do with configuration. So I can actually put configuration or default configuration into the Rails engine and have it be extended by my app and override it. And then database migrations and feed data. So it really does cover the full stack, what you're going to need to deal with in terms of reusing an app or using this engine in your application. So it was kind of funny. I was working on this yesterday, and my daughter, she's 11, she just turned 11. She's looking at this slide. She goes, "Dad, what are you, rainbows and unicorns?" And she's all big into, what is it, the pony, the My Little Pony. So she's like, "Dad." I said, "This is what I do at work." So everything in Rails has like a fun name or like an interesting name, at least what I've seen so far. So they have this in their tutorial. They have this blur engine, which is a blogging type of an engine. This is from the tutorial. And all this is showing is that I can reuse that engine
inside of my different apps. So I have Rainbow and Unicorn. And I didn't realize you were going to show Unicorn, the other Unicorn, not to confuse that server concept. This is just an application called Unicorn, okay? But pretty simple diagram here, but just kind of getting a point across. I can reuse that engine in multiple applications really easy. I could actually have, and I don't show it here, multiple engines being used in my application. I can have a hierarchy of engines too, which is really kind of neat. So real quick, extending the actual engine functionality itself. So this is what you find yourself doing a lot, is you're going to actually override and extend the actual models and controller classes. And here's where it gets interesting, and you know, from my Java hat again, I'm thinking it's just classic inheritance class. You know, obviously there's no interfaces in Rails, but not so really in Rails, or at least the way they do in the engine. What you're actually doing is you're opening classes, or you call it monkey patching, which really what it's doing is kind of interesting, is you're redefining or you're injecting more behavior into classes at runtime. So I have, and I'll show you this in a second in the code, I have a base class defined in my engine that has all the functionality, you know, generally I need. I'm actually in the application layer going to reopen that class definition, inject class methods, instance methods into that class, and then it's really a new version of that class. So it's monkey patching, opening classes. I don't know if you had experience with doing this, but yeah, everybody loves monkey patching, but which isn't a bad thing apparently. Overriding views. So you know, you have the capability. So the views again, you could define those in your engine, but you can override the actual view by name, by file, basically in your application. So if you wanted this different look and feel, what have you, in your actual application that's using the engine, Rails will look at the application for that view first. If it doesn't find it there, it'll go up to the engine. So there's this hierarchy, and that hierarchy actually follows for the configuration and initializers and so forth. So it's pretty good that way. So for those of you that you use Rails before, some real world examples, you may not even have realized this, but when you use Devise, is a very common authentication gem, but in fact, it's actually an engine. And that's actually one of the classic examples of, and thanks to Joel pointing me in this direction the other week. How does Devise do it? Well, Devise uses engines. You did, yeah, it was great. You pointed me in the right direction. So, but if you actually start looking at the Devise code, you know, they have, I'll get into this in a second, but they have something called a concern, which is a way to mix in code into your classes. But they have concerns for whether the class is authenticatable or it's lockable. So essentially, it's injecting all this behavior into your classes using the Devise engine. There's a couple others in here that I'm a little less familiar with, but they've been pointed to as good examples of, if you're going to develop an engine, take a look at these projects. So real quick, to generate a new Rails engine, everything in Rails, you know, you got your scaffolding generators and everything. Well, you can generate a Rails engine using this command here. Rails plugin, new, blur, and then mountable means I want to mount it inside of my application. I want it to have the ability to do this hierarchy or this inheritance kind of a concept. And then to use it in my actual application, I'm going to edit my gem file, which is my list of dependencies, essentially, the gem dependencies, and then tell it to just depend on my engine. And either you give it a path if it's local on your file system, or you could pull it from Git or a local repository. So let's take a look at the code real quick. Flip over here. Any questions so far? Okay. So I've already generated an engine real quick here for the Blur engine. And you can see here, Arthur showed you a little bit about Rails organization, but you can see here, this is a standard Rails type of directory structure. Inside of the app folders where all the goodies live, all your classes essentially. So you'll recognize controllers, your models, and your views. So in this particular example, I've just generated 3 different models that are in the base engine. So this is a blogging kind of application. So there's an article model, a base user model, and a comment model. And you'll see here, if I open up, for example, the article model, it has a many relationship to the comments model itself. So in Rails, this is how you start to define your relationships, has many, has one, those kinds of things. You see here a couple of things. If you're not as familiar with Rails, this won't jump out at you, but what happens is you see here these module definitions here. So this is basically namespacing this class as a blur class. So it's actually, again, in something like .NET or Java, packages. So this is the equivalent of packages. So this is trying to keep your code or your engine code separate from your application code, essentially. Makes sense, right? Okay, so this application, I've defined comments, comments and articles. The other thing that's nice about the Rails engine generator is it actually generates a dummy application for you in this test directory. So you see here, test dummy. And this is a full-fledged Rails application that's actually using your engine. So it does all that for you. So it makes it really easy to just start up a Rails server and test this very quickly. So I'll go into the blur folder here, go into test. And I'll just start up that application. I didn't go through, there's a couple of deployment kind of details like migrating my database stuff. I've done all that already. But so I started up my server, and if I go to the localhost 3000 port and the blur endpoint, we should see my application. So here's my base application. You can see here, I could generate a new article pretty quickly. Just title. And I could save that, and great, everything works. So this is my base engine, okay? So I've tested it. I've also had the ability to write automated tests. So again, this is really good about generating tests for you or generating the frameworks for tests. There's different types of test packages you could use, but you can see here it started to generate a test for my models. It automatically generates that code. So I can run all my tests here, make sure everything's great. So the next step is I want to use that engine now in an actual app. So I have here my Unicorn app, which I've generated. And you can see here that the directory structure is very similar. So again, there's a lot of similarity between a Rails engine and an actual full-fledged app. The one thing I want to point out is that the gem file for this application, you can see here that it's actually including blur itself as a gem. So that brings my engine in. Okay. And if I just switch over, now I'm going to kill this server and go over to my, my blur, my Unicorn. The Unicorn app. I'm going to fire up that app real quick. Now, I didn't do anything to this app. I didn't put any code into it. So it should work identically to the engine itself that it is using. The only thing I want to show is, before I do this, is that when I'm in the Unicorn app, there's a routes file, and again, this sets up your URL to controller mapping. So which controllers do I actually utilize for a URL? There's a command here or a directive mount. So it's telling it I want to mount the blur engine at the endpoint /blog. So all of the controllers and routes that are defined in my engine are now automatically brought into this app, which is really nice too. So another way to separate out or componentize your functionality. So if I just switch here, now again, I'm running the Unicorn server. I'm going to change the URL here to blog. I should essentially see the same app. Now, this is a different database, so I didn't see that article, but it's going to function the same way. So nothing too exciting here, but it works the same way. So the last piece I want to show you is actually now how do I customize or extend the functionality of my engine in my Unicorn app. So in the Unicorn app, what I want to do first is, actually, I'm going to have to switch a second here.
Your migrations run to
yeah, migrations. Yeah, you have to do a so migrations are database scripts that run in Rails. you define migrations down in your engine, but there's either a script command, a rake task that copies it over to your application, or you may need to do it yourself. So migrations are a little bit tricky because you still need to maintain some order, especially when you're developing your engine and your app at the same time. You got to be careful with that a little bit. So I'm sorry, I just had to switch a branch. So what I want to do now is start to extend the functionality of the engine in my app. So what I'm going to show real quick is in the model, I want to extend the article. I want to have the ability to have article be extended. So what I'm going to do, and this is where it gets different, what I want to do is actually wrap my article class, or it's not actually, is define the article class functionality as what they call a concern in Rails or Ruby. What that is basically is, are you guys familiar with the concept of mixin or injecting? So it's not really behavior. It's actually a way to achieve multiple inheritance, really, in this case. So what I want to do, basically, what this is telling is that I want to inject some class methods into whoever includes this mixin. It'll actually mix this some class method in. I want to actually inject this instance method called summary into whoever includes this mixin. And then you also see this included block up here at the top. That's actually executed, or a method that's executed when you actually include this concern into a class. And it basically allows you to call class methods at the point at which the concern is actually included into your class. So this is a little bit of meta programming in Ruby and Rails. So I'm going to do that in my base layer, my engine. And in the base layer for the actual model class itself, you'll see here that the class, all it needs to do is say includes this concern. That injects all that behavior into the engine class for article. Over on the Unicorn side, which is the app that's using this, now I want to basically extend or add to that engine class. So the way I do that is, first I got to change, sorry, my branch here. Okay, so the way I do that is in the same data structure, or same package or directory structure, the models blur folder here, I have my article. So this is where I'm starting to redefine or reopen the class. So this is again on the Unicorn side. I have my class blur article, but you see here now I'm telling it to include the concern that I defined before from the engine. But here's where I'm starting to essentially override or add to that class. So this isn't, again, it's a little different than in class inheritance. This is mixins, and I'm overriding basically class and method functionality. So essentially, I'm defining a new instance method here called, or actually, I'm overriding the instance method called summary, which is returning the title and the text. So this is just a quick example of using a concern in your app. So to really demo this quickly, I think this is in Unicorn still. The other thing that I did, actually, sorry, is I created an override for the show view here. And what I did is, instead of showing the title and the description separately, I'm now in the Unicorn app just showing the summary. Sorry, go ahead.
Is that a mix override?
It's injecting. What, sorry? Yeah, I mean, it's a solution for multiple inheritance. Yeah. Right, Java. I mean, in Java, you're going to have multiple interfaces that you have to implement, or yeah, essentially. Right. So this is the way you would deal with that in Rails. So if I refresh this, you see here now, I don't know if you remember from before, but now it has a summary field in the view, and it's pulling the summary field. So if I go back here and create a new article, and I show that one, you see here now it actually pulls together the title and the test. So essentially overridden a view and extended or inject or added the mixin to the base class to achieve that. So just a little bit of an example of how I can use and extend the view.
You can call super.
Yeah, but super is going to call your actual class you extended, not the mixin class. You're talking about within the mixin, or
Okay, so
super, because I'm still extending the active record base. I'm sorry, super in the summary class, or
if you call super in the method you overrode, is it going to call it from the?
Yeah, that's a good question. Actually, I'm not sure.
Okay.
That's a really good question. I'll have to try that. Anyway, so some lessons learned if you're going to do this. This again, I've just recently have been doing this. So one of the things I ran into, because what we did is took an existing application and sort of broke it up into a core piece and the actual application part. You have to be really careful with the engine, the module namespacing, because you're going to have to go through your code and start to namespace all the core classes, whereas before they weren't. That's obvious. But with Rails, because it's all convention over configuration, when you start to have model classes and modules, it starts to name tables with the prefix of the modules. So table names started to change on me. So that's just something to look out for. Relations sometimes get a little tricky. I didn't show in this demo, we don't really have time right now, but if you are relating to a base class in your application, that's really no issue. But if they're in your core class, you want the ability to relate to something in your actual application class. That's when it gets a little bit trickier. And there's some patterns in that tutorial that shows you some ways to do that. We recommend that you refactor your common classes or your core classes, your engine classes into concerns so they're all easily extendable. It's not hard to do that. It's just a little bit tedious. You have to go through all your classes and do that. Include your file system reference to the engine gem during development. So you saw, I don't know if you remember in my gem file before, I'm actually referring to just a local instance of my engine, not pulling it from Git. So I'm doing my development, in this case, side by side with my application. And then on my CI test deployment builds, I'm actually pulling specific versions of the core over there. I haven't really tackled the whole UI part of this, because we're actually using Angular on our project for this. And I showed you a little bit of how Rails does its view overriding from an engine perspective, but that doesn't really tackle or cover if you're using Angular. Angular has a whole other way of modularizing and so forth, and that's probably a topic for another time. And then from a testing perspective, definitely recommend having a standalone set of tests for the engine itself, so you're validating that your engine is doing what it should do before you include it in any of your applications. That's something that we need to start porting back our tests to. And even in your application, because you might be overriding or extending some of your engine functionality, you still need to make sure you cover that functionality in your application itself. So, if I add additional validations or so forth to the engine model, that's not going to get covered in my engine test functionality. Obviously, you need to consider that when you're in your application testing phase. So, any questions, additional thoughts? Performance? From what perspective?
Well, I mean, you're changing things on the fly. Like, how do you load test it? How do you look at how does it perform?
Yeah, so I think it's in terms of like reopening classes and things. It's the kind of Ruby was designed from the ground up to be able to do that, and actually it's doing that in a lot of other places like gems EUs and so forth. So I don't think you would feel any difference in performance from that perspective.
That's the theory.
That's the theory, yeah. I mean, what was the other performance?
Well, I mean, there's the practice. Have you measured it or tried it?
No, in fact, I mean, again, full disclosure, I've just recently done this on my project, so we're just starting to feel some of the pain I just went over. We haven't noticed any performance issues itself, primarily because, again, it just kind of gets all munged together as one app still. You're reopening classes and all that, but it's not going through any more overhead, I guess, than it would if it was just a single monolith application. for the most part, yeah.
If the benefit is something,
yeah, I mean, that's a huge benefit, yeah. So again, coming back to the first slide, is our customer wants something very similar, but it's a different domain, right? It's a different function. But we're going to reuse a lot of the same pieces like workflow and admin and security and all those pieces. So, and again, I'm sure you've all dealt with this on other projects, any larger scale application. Or if you haven't, you need to think about this when you start your project. If it's a success and your customers want more of the same, it's a lot cheaper to do this up front in any technology you have. Think about these things up front as opposed to re-engineering it later on. So here's some references. I know some of you guys are new to the whole Rails and even the engine concept, but these are some really good tutorials and descriptions of Rails engines and using concerns and so forth. And the code I showed you is available as well if you want to poke around a little bit. So that's it.